This is Lesson 4, Section 5, Metamorphic Processes. While you were at Antelope Island admiring the wavy rocks, your guide passed out chocolate chip cookies. As you ate, you thought about how cookies are made. You mix the dough, shape it into balls, and then bake them. Which type of rocks does this remind you of? Cookies are a lot like metamorphic rocks. The ingredients in the cookie dough are like the different minerals in the rocks. You squeeze and roll the dough into balls. Too much pressure causes the dough balls to deform. You cook the dough by placing it in a hot oven. Heat causes the ingredients to change in appearance. Metamorphic rocks can be grouped into two categories based on how they form. Some metamorphic rocks form when rock over a wide area is deformed by heat and pressure. Other metamorphic rocks form when minerals recrystallize or form a new crystal structure because of the heat from nearby magma. Deformation is when two tectonic plates push against each other. Enormous pressure is placed on the rock. Over time, tectonic forces and heat can cause the solid rock to deform. As the rock deforms, its crystals change shape, often becoming longer and thinner. They also line up parallel to each other in bands. Pressure can bend the bands. As Figure 5a shows, deformation can cause existing rocks to change into metamorphic rocks, such as schist and gneiss. So here we have Figure 5a you can see on your screen. Metamorphic rocks. It says metamorphic rocks form when existing rock undergoes changes due to high temperature and pressure. When tectonic forces push on the rock, they cause it to deform. Schist and gneiss are examples of metamorphic rocks that form by deformation. So in the picture it says that when an existing rock is exposed to moderately high temperatures and tectonic forces, its mineral crystals become longer and thinner and line up parallel to each other. This would be like a schist. And then when the existing rock is exposed to very high temperatures and tectonic forces, its mineral crystals separate into parallel bands, like the gneiss. Recrystallization. Recall that conduction is the transfer of energy from a warmer object to a cooler object when the two objects are touching each other. When magma intrudes into existing rock, heat is transferred from the magma to the rock. Together with high pressure, this causes the minerals in the rock to recrystallize. This means that the atoms of the existing crystals get rearranged to form differently shaped crystals. This is similar to what happens to cookie dough on a hot baking sheet. As the baking sheet heats up, energy is transferred from the sheet to the dough. As the dough becomes warmer, its ingredients change form. Figure 5b shows two examples of how recrystallization changes existing rock into metamorphic rock. The sedimentary rock quartz sandstone forms the metamorphic rock quartzite. This happens as the quartz crystals in the sandstone form new, larger quartz crystals. Likewise, the sedimentary rock limestone forms the metamorphic rock marble. This happens when the calcite crystals in the limestone are restructured to form new, larger calcite crystals. Figure 5b. Let's take a look at the picture. Recrystallization takes place when existing rock is exposed to high pressure and magma below Earth's surface. The heat from the magma causes the surrounding rock to recrystallize, forming new metamorphic rock. Quartzite and marble are examples of metamorphic rocks that form by recrystallization. So in order for quartzite to form, the sandstone gets exposed to very high temperatures. It has to be the quartz sandstone, and then quartzite will form after it's exposed to high temperatures. When the sedimentary rock limestone is exposed to moderately high temperatures, it forms the metamorphic rock marble. The amount of recrystallization depends on the distance of the rock from the magma. The rock closest to the magma undergoes more change than the rock further away from the magma. This is because the rock closest to the magma is heated up more than the rock that is further away.